Linear combination and spanning set. Let's try to see how to write a vector in terms of linear combination of the spanning set, and we'll thereby also understand what does it mean. The question is, show that 10, 7, this is a vector, can be written as a linear combination of set of vectors 2, 1 and -1, -1, right? So take this as a vector. So that is the question. So that really means that we have to write this vector 10, 7 as linear combination of these two. Linear means A times the vector 2, 1 plus B times the vector -1, -1 should be equal to the vector 10, 7. So that is what we need to do. It says show that, I've missed the word vector, add it here, vector. Show that vector 10, 7 can be written as a linear combination of set of vectors. So this is a set of vectors having these two vectors, 2, 1 and -1, -1. So linear combination is you multiply this by some real number and add it to another scalar multiple of the other vector. So A and B belongs to the set of real numbers in this case, right? So we need to find what is the value of A and what is the value of B, which will give us the desired vector 10, 7. So that is what is to be done. So let's do scalar multiple here. So using properties of scalar multiplication, we can expand this, right? And this can be written as, we can write this as 2 times A, comma, A plus minus B equals to 10, 7. Now, in case these vectors are equal, then the sum of these should be equals to 10 and sum of these should be equals to 7. Why? These are the components of the vectors, correct? And when we add them, let's apply the property of vector addition and add them first. So when we apply the property of vector addition, we get 2A minus B, comma, A minus B. We get a vector 2A minus B and A minus B on the left side equals to the vector 10, 7. Now if these two vectors are equal, then their components should also be equal, correct? So that gives us two equations. Equation number 1 will be 2A minus B equals to 10, and equation number 2 will be A minus B equals to 7. Right? So we got two equations. Let's number them as equation 1 and equation 2. Right? Now these are two equations. We can solve them by elimination and find the value of A and B. Right? So let's do that. If I take away equation 2 from 1, that is to say, let me do it on the right side. If I do equation 1 minus equation 2, what do I get? 2A minus A is A, minus B is 0, so A is equals to 10 minus 7, which is 3. So we get the value of A as 3, right? Now once you know the value of A, you can find value of B from equation 2. So let's substitute this value in equation 2. So we get from here 3 minus B equals to 7, or we'll bring 7 to this side, 3 minus 7 equals to B, and thereby we have B equals to minus 4, correct? So we found the values of A and B. So A is 3 for us. What we got is A equals to 3 and B is minus 4. So we can now write 10, 7, the vector 10, 7 as equal to 3 times 2, 1 plus, which is minus 4. So I am writing minus, B value is minus 4 times minus 1 minus 1. So that becomes the linear combination of these two vectors, which will give us the required vector.